So this talk will be about thread pools. So some of you may know a lot about thread pools, some of you may not. However, let's talk about what I'm hoping you'll get from this talk. So first of all, to get a greater understanding of how the tools you use affect your app's performance in ways maybe you didn't realize. With that knowledge, hopefully you can create faster, snappier, and more performant apps. And also just be able to understand the topic so you can discuss it in your workplace with your colleagues. So if we look at the example of coroutines, so we have these dispatches. So default, as you all know, is for saving memory to disk. I/O is for networking. And if I was to ask somebody, how large is the thread pool for this, I wouldn't be surprised if you didn't know, but some people might say 4, and that seems logical, right? Because we have 4 functions here. However, if we look deeper into the code, I've highlighted in red the default dispatcher, and in yellow on the bottom, the I/O dispatcher. If we look at the default dispatcher, we can see that the pool size, it says available processors with a minimum of 2. So the reason it's like that is because saving memory to disk is a very intensive process. So we don't want to make too many threads available. And if we look at the I/O scheduler, we can see we have 64 threads with a minimum of as many available processors. So if we ask the question again, how large is the thread pool? Well, we can see we have at least, let's say, 66, and that's only looking at default and I/O. So why does this matter? So I believe it matters because all of the libraries that we're using, well, not all, but a majority of the libraries that we're using have their own thread pools. So we have room, which is for saving memory to, memory to disk. We can imagine that has as many threads as there are processors as well. And then we have all the other libraries, OK, HTTP, ExoPlayer, Picasso. And what's interesting is that we have coroutines and RX, and it's not uncommon to use both of these libraries in your code base at the same time. And the same for libraries like Koyo and Picasso if you're using Compose and XML. So you have tools that do the same thing, and each of them are creating their own thread pools. On top of that, there are many processes that we can't control that also have their own thread pools, such as garbage collection, the Android OS in general, and Google Play services. So if you need to use somebody's location, well, guess what? That comes with its own thread pool. So what I wanted to do was to get an understanding of how many threads are created when running a very simple app. So I have this example. It's an app that allows you to walk around a city, and once you're done with your walk, you can open it up and it will show you a list of all the images of where you have walked without you having to take photos. So the way it works is that we fetch your location every 200 meters. We send it to Flickr. We get an image, if it exists, that represents that location. We save it to room, and then we display it to you. So it's a pretty standard offline first pattern. So this is what it looks like if you're walking away from the Eiffel Tower in Paris. And if we run this line of code while the app is running, we can get a list of all of the threads that are being produced. And here is an example. So in gray, I've highlighted all of the threads that are being created by processes that we can't control. So we have the Android OS, we have garbage collection, which is called Finalizer. We have Google Location as well, including memory management. And then in white, we have all the threads that are being produced by the libraries that we're using all the time. So we have coroutines with 5 threads, OKHTTP with another 5 threads, and we have room with 4 threads. So my question is, can we reduce the number of threads that this small application is using? And the answer is yes. We can create our own thread pool executor. So this is nothing innovative. You can find this if you search online. But basically, what I'm doing is creating my own thread pool. So I've set a core pool size of the amount of processors available in the device. The max pool size I've just set to max value. And then the keep alive time, that basically says how long to keep a thread alive after it stopped being used. So we have here 60 seconds to recycle a thread before we just bin it and allow it to be destroyed. So once you've created this, how can you use it? So in OKHTTP, it's extremely easy. With the builder pattern they have, we have the dispatcher. We can just pass in the thread pool when we're instantiating OKHTTP. With coroutines, it's a bit more difficult. This is not all the code you need, but it's just an example. So when you're instantiating it, you can pass in the thread pool executor. You can mark it as a coroutine dispatcher. Then within your view models, this is how you inject it, the second line of code. You always have to use this annotation. And then when you are in the view model, you can just use it like that, just the view model scope as you would usually. So it wouldn't take away from, how you would usually work. And so what happens when we run this code again? We can see that we produce fewer threads. So all of the coroutines threads have been removed. All of the OKHTTP threads have been removed. And of course, the room ones have stayed. That's because we created the possibility to create so many threads. So it wasn't, the shared thread we created wasn't, the right type of thread pool we needed for room. So, right, the question is, are there disadvantages to doing this? There are. There's something, concept called thread starvation. So if you can imagine, if you have the ability to create 64 threads and you have 66 operations that need to run, 2 of them are going to be starved off a thread and they're going to be waiting around. This is less likely to happen if you just allow all of your libraries to create their own thread pools, because then you'll essentially have unlimited amounts of thread pools and thread starvation never occurs. Another potential issue is task priority issues. So if you can imagine, if you have OKHTTP and COIL, OKHTTP could have a higher priority than COIL. This means that you download all of your text before your images. However, if both of these libraries are using a shared pool, thread pool, apologies, there's no priority. So you might end up with some images being downloaded, some text, some images. So these are 2 things to consider if you want to create a shared thread pool. So should I create shared thread pools? No, and this is not really what I'm advocating. I'm just giving you an idea of what can be done. And I believe creating shared pools should be, I guess, the last step you should take. So preferably, if you have a large application, you might have something like this, right? You have an app, you have countless modules, some modules you haven't touched in years, and you may find you have stuff like this happening, where you have instances of COIL in multiple modules, and even beyond that, you might have multiple cases of Picasso across multiple modules. So in this case, instead of creating a shared pool, what you can do is refactor your code to ensure that you only have 1 instance of Picasso and only 1 instance of COIL. That's probably the first step before you start creating a shared pool. And then you have a look at how your app is performing. again, you can have multiple instances of OK HTTP, and then, of course, coroutines and RX. So as I said, your best case scenario here is to ensure that you only instantiate one of each of these libraries. And then if you are in a situation where you have Picasso or Coil, you could consider having a shared thread pool for these libraries, because they do essentially do the same thing. The same for coroutines and RX. So the key takeaways from this talk is that many popular libraries are built in with their own thread pools. So they're not completely free to use. Creating multiple instances of them increases your thread pool count. It is possible to share a single instance of a thread pool between these libraries. And every additional thread pool takes up additional memory and CPU resources. And yeah, thank you.